We're now going to look at how searches operate on a computer, and there's two types of searches that we're going to try and understand today. The first one is a linear search and the second one is a binary search, and the advantages and disadvantages of each type of search. So it's linear and binary searches that we're going to be looking into today. So with a linear search, what we actually do is we look along a list. So linear meaning line, and we can look along the line of the list to say where something is in the list. So each item is stored in position, so like position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can look along the list to find the item. So here we're trying to find the number 54, or the item 54. And we start here at the first item. So this is location 0. This is 17. So it's not this one that we're looking for. It's not the 54. So we move on to the next item. Then we're looking at 20. It's not that. So we move on to the next item. So this is location 0, 1, 2. It's not there. We move on to 31. It's not there. We move to 44. It's not there. We move along and we find 54 here. So this is in location 0, 1, 2, 3, 4, 5. We found it at index 5 when we were searching. So just a recap of that, we start and we move along in a linear fashion, hence why it's called a linear search, just moving along until we find the item we want. Now, linear searches have advantages and disadvantages. The fact that the information doesn't need to be in any particular order. It doesn't matter that the numbers are ordered, we will still eventually get to the item that we want. So that's one advantage to a linear search. The data doesn't have to be ordered. Another advantage is that you can search for items that have no order in any way. So this could be colours. You could have blue, green, red, orange, yellow, pink, maroon. It makes no difference the order of those colours. You just move along from one to the next until you find the item that you're looking for. And another advantage is that in computing it's very easy to code a linear search. So you're just telling it to go through a list, indexing through a list or iterating through a list until it finds what it's looking for. If it's a match for what it's looking for, great, it's found it, and then the search can stop. And the difficulties, the negatives, the cons of linear search is that it's inefficient. It's all right looking through this if you've got a short list of items, but if you had 1,000 items to look through, it could take you some time to find the item, especially if the one you're looking for is at the end of the list. So the time taken to search gets longer as the size of the list increases. So that's the negative of a linear search. If we look at the flowchart of a linear search, we can see here it's fairly easy to understand. We start and we set our index to 0. We then look, does the list item contain the search criteria? So is it there when we look at our first item? Is that what we're looking for? If it is, we've found the item and we just note what our current index is and we end. If it's not the item we're looking for, we add 1 to our index value. So index equals index plus 1. So we just add a total of 1 to that. So we start off at 0. It now becomes 1. And then have we got to the end of the list? If we haven't, we then look for the next item and then add 1 and keep looping around until we find our item. If we have found our item, then we move this way, match found, and we end. If we get to the end of the list and our item is not in there, then again we just end our search. So this is the flow diagram for a linear search. When it comes to programming a linear search, I said it is relatively easy, and I'd like you to program a linear search in Python or using REPL. So I'm just going to repeat this as we've got it here. So I'm defining, we've not done much with defining programs before, but defining means a subprogram. Defining linear search. So that's what my subprogram is going to be called, and we're looking for a list, comma, criteria, and then colon. So what I'm now looking for is setting up my value of match equals false. So this is a Boolean value, we're setting it to false, and we're saying then that our index equals 0. That's our starting point. Iteration, so how many times we've looped round, iterations equals 0. So we've set our initial data. Then we're going to put in a question. So we're going to say while not match, so if it's not the same, and index is less than the length of the list. And when we're programming this, we need a colon at the end. What you need to make sure is list here is spelled exactly the same way it is here, so with a capital L, and index here is spelled the same way as this index with a capital I, and match same as this match. You've got to keep your variables the same, otherwise it's not going to be able to find it. So what we're saying is if the list at the index, again keeping the items correctly spelled, and we're using a square bracket on this one, so index, and then what we're using is equals equals, which means is the same as. So if it's the same as criteria, and again this needs spelling the same way it's spelt up here with a colon at the end. If it's the same, what we're saying is match equals true. So it has to be a capital T to turn it into a Boolean variable, true. And I've pressed enter, and you'll notice that I'm still indented. I need to press backspace to get my tabbing in line with the if, because we're doing an else and a colon. So if we've got an else, what we're going to say is index plus equals 1. This is the same as index equals index plus 1. It's just a shorter way of writing it. So we're just adding 1 to our index value. And then I'm backspacing again, and I'm saying that iterations plus equals 1. So we're adding 1 to our score on iterations. Again, iterations should be spelt the same as it is before. So that's what we have so far. Now we're looking for our message if we do find a match. And if we look at the if here, it's level with the while. So I need to backspace. If match, colon. So if it is a match, I then need to print a message. And I need to just print, we could put the \n as in the example on the screen here, \new line. We don't need to, we can just leave it as it is. What I'm going to do is criteria. Click in there. Criteria, comma. So that'll be whatever number we're looking for. So what index it is, criteria. Speech marks was found at location or index. Was found at index. And then we need to say what the index is, so I can put a comma in there and then using this variable index. So if it was found at that index. And then we can also say what our total iterations were. So we can have print total iterations were the iterations. So let's just put that in as well. So print total iterations, comma, iterations. So that'll count how many times it had to go through the search to find it. Iterations, just checking the spelling is the same as the spelling up here. So we're getting there. It looks a long bit of code, but it's not too complex. We're now building in the else. So if it's found the match, it will say that. Otherwise, so else, we've got a print, and this time we're going to print criteria. Criteria. Speech marks was not found in the list. So speech marks bracket. And again, we can print how many iterations we actually went through. So total iterations, comma, iterations. Need my speech marks in there. Total iterations, speech marks, comma, iterations, bracket at the end. Now all we need to do now is define what is our list. So again, I've lined this up level with my defining, and again here where we've got the def, it's all in line. So the list of items that I'm actually looking through, and these are just the numbers we're going to look at. So I've got a 17, a 23, a 45, 67, 34, 108, 3, 190, 21, and an 81. So what I now have, I'm just going to do one of these, linear search. So that is the program, and I'm looking for list for the number, whatever number I'm looking to find. So I'm going to try 108 first of all, 108. So now when I run this, look to run my code, I'm hoping I'm not going to get any errors. I don't get anything. Run. Let's have a look. Why I don't even get an error message. What I've not told it to do. There we go. It took a little while. I don't know why. Total iteration 6. So it found 108 at index 5. So we're looking at 0, 1, 2, 3, 4, 5. It found it at 5, and it had to iterate through 6 elements to find it. 1, 2, 3, 4, 5, 6. So that's what it's done there. I'm not quite sure why it took so long to run that code. It shouldn't have done. It should be quite quick, but it worked. What I'm now going to do, if we look at the next bit here, linear search, list 81. So I'm looking for item number 81. So before I run this, I'd like you to have a guess as to what the answer will be. So we've got list, comma, 81. So it will run the 108 one again. In fact, I can take this one out so it doesn't run that. So now we're looking for list 81. So we can look at our list. Will it find the number 81? At what location, and how many times will it loop through to find it? So again, I can run it. Let's find. So it was found at index 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. With total iterations of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, when we're indexing, we start from 0. That's why they're different in the numbers. So you need to try and run this code and explain what's happening. The final one we're going to look at is if I'm looking for the number 82 in the list. So I'm going to look for the number 82. So we can look through the list. Now obviously we can do this manually, but if this was a long list, the computer would do this for us, so we can import our data and then look for it. That's why a computer will run a linear search. So you could say, why do you bother programming this when we can just do it? But obviously if we've got more data, we'd want the computer to find the information for us. So is it going to find the number 82? I'm looking through the list as a computer would, linear search, starting from the first one, moving on as I go, and it can't find it. So I'm just going to click run, and 82 was not found in the list. Total iterations 10. So it went through 10 and couldn't find it because it wasn't there. So that is what a linear search is. So if we look at a linear search, what we have now is our code for a linear search. Maximum number of items that would have to be examined to find a match in a list with 1,000 items. You can work that out, and that would be therefore how many times would it have to go through it at most. You can have that answer in your work. What's the minimum number of items, and what's the average number? What is the total number of items that would have to be examined if there was no match to search criteria in a list with 1,000 items. And when we search a list, what is the index of the first item called? What's this item here called? So that is a linear search. I'm going to pause the video here and you can have a go at those questions.